Continuing with our Chapter 1 review, looking at questions 3 through 5. So, number 3 on the review, it's a limit. Every time we have a limit, we need to just try to plug it in first. Usually, the problem is going to happen on the bottom, so you can even start with the denominator. You need to be very careful with this problem because in the denominator, we have -1 squared plus 1. Now, if it was just -1 plus 1, that would give us a 0, and that would not work. However, this is -1 squared. This is why it's important to put parentheses around what you're squaring. Because this is -1 squared, it becomes a positive 1, and our problem becomes 1 plus 1 on the bottom. Since it's 1 plus 1 on the bottom, it's 2, not 0, so everything is fine. So all you have to do for this problem is plug things in. On the top, we have -1 squared plus 3 times -1 plus 2. So that becomes positive 1. -1 squared is positive 1 minus 3 plus 2. So then we get 2 on the bottom, 0 on the top. This is okay. It's okay to get 0 on the top. That just means that your answer is 0. So our answer to this limit is 0. If it was on the bottom, then we'd have to factor and try to do something else. But that's not the case with this problem. We just plug in and get our answer. Looking at number 4. So let's try the same thing. As long as we're not going to square root a negative, we're good to go. So we don't need to write the limit because we're plugging in the 3, so we're using it. So this becomes the square root of 3 squared, put that in parentheses, minus 4, which is 9 minus 4, the square root of that, which is the square root of 5. And that's it. Leave your answer like that. Don't go get a decimal. You're not going to have a calculator on the test anyways. There's no reason to do that. Leave it like that. Since this problem had a square root in it to begin with, we do not need to put a plus and minus here. You only put a plus and minus if you are solving and you are the one that put the square root in the problem. Since this square root was already there, we only take the positive answer every time. Okay. Looking at number 5, we are evaluating this with limit rules. So when we evaluate this, this says the limit as x approaches c of f of x is -1/2. The limit as x approaches c of g of x is 2/3. Now find the limit as x approaches c of f of x divided by g of x. Well, if we're going to do that, our limit rule says that this is the same thing as the limit as x approaches c of f of x divided by the limit as x approaches c of g of x. So when we do that, well, they've told us the limit as x approaches c of f of x is -1/2 divided by, they've told us the limit as x approaches, c of g of x is +2/3. So all we have to do is simplify this. A fraction divided by a fraction, you use keep, change, flip. Keep the -1/2, change the division to multiplication, flip the last one, so it becomes 3/2. When we multiply fractions, you multiply everything on the top, and then you multiply everything on the bottom. So we have -3 on the top and +4 on the bottom. And that's our answer. And that's it for these 3 problems.